So what are the main features and benefits of the instrumentation? As everyone will know, there are many other particle sizing instruments out there. I always like to say that these other techniques are very complementary, and you should always use more than one technique when you're characterizing your material. When it comes to the CPS disc centrifuge, one of the main benefits you'll find is the ability to give ultra high resolution, which means when you are characterizing a sample where you have many peaks, and in this example, let's say we've got a polystyrene mixture, we've got 9 peaks, and as you will see from the distribution, we can actually separate all 9 peaks and resolve them and show them clearly on the screen. So here we can separate, detect and characterize particles down to 2 to 5% difference in size. The CPS technique is a great technique for looking at very small concentration of material, so it has extremely high sensitivity. In this particular example, we've got a very broad peak, nothing very exciting about this, but if we zoom into the actual trace, we will see that we've got a very small peak at high particle size, which is almost hidden at the baseline, but this peak is real and it's representing a certain percentage of large particles. And in most cases, you'll find that this small peak is of more important than the actual main particle sizing peak. The CPS technique is accurate, reliable and reproducible. And in this particular example, we've ran a PVC sample 5 times, I believe on 5 different instruments, 5 different conditions. When we overlay the runs, we get almost identical data. How can that be? Each time the instrument is used, it may be used at a different disk speed, you may have a different gradient, different user. Why do we get the same results? The reason for this is because before we run a sample, we always calibrate the instrument, meaning we run a sample of known size and known density, and we are able to use this to convert the time axis to particle size for the material that you're examining. Everyone would like to be able to image the particles and see what they can under a microscope. And we have a lot of evidence to show that the size distribution you get with the CPS instrumentation does match what you see under a microscope. There have been a lot of studies where users have been using other techniques and they've seen the large particles and not seen the smaller ones. However, being a separation technique, the CPS will separate the large and the small, so your distribution is of the whole sample, it's real and it matches what you can see under a microscope.